Hello, everybody. Today we're going to talk about zero and negative exponents. So, this is some really good, interesting stuff. Here's a theorem for you. Anything to the zero power equals 1. Or better yet, a to the 0 equals 1, where a is not equal to 0. So what we do not want to have is this situation here, 0 to the 0 power. That's not a thing. Okay? So, yeah, we don't want that. So any other number, though, to the 0 power is 1. So 4 to the 0 power is 1, 100 to the 0 power is 1, negative 2.5 to the 0 power is 1, 20 bajillion to the 0 power is 1. Okay? So, that's always pretty easy. Now, why is this? Okay, so let's look at why this is. So if I take 4 to the 4th power, that's going to be, what, 256? And 4 to the 3rd power is 64. And 4 to the 2nd power is 16. And 4 to the 1st power is 4. Now, if I look at each step here, going from here to here, I've divided by 4. 64 divided by 4 is 16. 16 divided by 4 is 4. So if I keep this pattern going, if I take this and I divide by 4 again, I'm going to get 4 divided by 4 is 1. Okay? That should be green, my friends. That's 1. Okay, so let's look over here. 2 to the 4th power is 16. 2 to the 3rd power is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. So each time that I go down 1, I divide by 2, right? Divided by 2, 4 divided by 2 is 2. So if I do that again, I divide by 2 one more time, I'm going to get 1. Now this works really good if you look at 10 to the, let's say, 3rd power, that's 1,000. Okay, and 10 to the 2nd power is 100. And 10 to the 1st power is 10. I suppose we can do 10 to the 4th power here is 10,000. So you see what happens here is every time I go down, I lose a 0, right? So if I go down one more and I lose a 0, I get 1. That's why anything to the 0 power is 1. Okay? Piece of cake. Okay. Well, what about negative powers? Well, for negative powers, we just continue the pattern that we saw on the previous page. Okay? So, let's check this out. So, here, wait. Don't want to give it away too soon. So, 256, 4 to the 4th power, 4 to the 3rd power, 4 to the 2nd power, 4 to the 1st power, 4 to the 0 power, right? We go down by 4 each time. We divide by 4 each time, right? So divided by 4, divided by 4, divided by 4, divided by 4. Well, I continue that pattern. So I take 1 and I divide it by 4. Whoa, I don't know what happened there. I divide it by 4 and I'm going to get 1/4. And I take 1/4 and I divide that by 4 and I'm going to get 1/16. And I take that and I divide that by 4 and I'm going to get 1/64. Okay. So this is just 1 over 4 to the 1st power. This is 1 over 4 to the 2nd power. This is 1 over 4 to the 3rd power, and so on and so forth. So when I have a negative exponent like this, all that means is I take this number and I put it in the denominator. Okay? So I take 4 to the 2nd power and I put it in the denominator. I take 4 to the 3rd power, I put it in the denominator. Okay, same thing here. If I look at this one, I divide by 2 this time. And I divide by 2 this time, and I keep dividing by 2. And I divide by 2 one more time. 1 divided by 2 is 1/2. And then 1/2 divided by 2 again is 1/4. And 1/4 divided by 2 is 1/8. Okay, and so on and so forth. So another way I could write this is 1 over 2 to the first power. This is 1 over 2 to the second power. And this is 1 over 2 to the third power. Okay, so when I have a negative exponent, I just lose the negative and I put the power in the denominator. Okay? Unless it's already in the denominator. If it's already in the denominator, then I move to the numerator. Okay, so here we have a theorem. For any integer n and any non-zero number a, so a can't be 0, a to the negative n is the reciprocal of a to the n. Remember, reciprocal means take a fraction and flip it over, right? So 5 to the negative 2 is 1 over 5 to the second, which is 1/25. And in general, a to the negative n is 1 over a to the n, where a is not equal to 0. Okay, now, like I said, if I have something like this, where the negative power is in the denominator, now I flip it to the top, and that's just 25. Okay? So 1 over 3 to the negative 3 would be just 3 to the 3 over 1, which would be 27. Now here's a weird one. What if I did this? I've got 2 to the negative 2 power over 3 to the 4th power. Whoops, that's not what I wanted. 3 to the negative 4 power. Okay, well I got negative powers on the bottom, I got negative powers on the top, which means this goes on the bottom and this goes on the top. So this is equal to 2 to the 2nd power in the denominator and 3 to the 4th power in the numerator. So that'd be what? 81 over 4. All right. So evaluate this. 3 to the negative 4th power. Well, that's going to be 1 over 3 to the 4th power. And 3 to the 4th power is 81, so this is 1 over 81, and you're done. 8.5 to the negative 4 power. Negative 8.5 to the negative 4 power. Okay, so this is going to be 1 over negative 8.5 to the positive 4 power. All right, so I'm going to get out my handy-dandy TI-84 plus C Silver Edition graphing calculator at this point. And 8.5 to the 4th power is going, that's going to be 1 over 5,220.0625. All right, that's kind of ugly the way I wrote that. There we go, that's better. Okay. Okay, 2 to the 6th over 2 to the 8th. Now remember, when we're dividing, this means that we subtract the exponents. We did that last time. So this is going to equal 2 to the negative 2 power, which is 1 over 2 to the 2nd power, which is 1 over 4. It's really not that difficult. Okay, so you get to try these, so I'm going to have you pause the video here. I'm going to have you solve these, should take a couple minutes, and then jump back on here and we'll do them together to see how you did. Ready, set, go. Pause the video. Okay, let's start with this bad boy right here, negative 2 to the negative 5 power. So first of all, it's going to be 1 over negative 2 to the 5th power. Let's see, 2 to the 5th power, that's 2, 4, 8, 16, 32. So this is going to be 1 over negative 32. Okay. Let's look at the next one here. 4 to the negative 2 power. So that's going to be 1 over 4 to the second power, which is 1 over 16. All right, this one looks a little tricky. 6 to the negative 8 times 6 to the 6th. So we had our property of multiplying powers, which says this is 6 to the negative 8 plus 8 power, which is 6 to the 0 power, which everybody knows is 1. So that was pretty easy. Okay, negative 3 to the 5th power. We have no negative exponents here. Oh, well, let's here over negative 3 to the 6th power. That's going to be negative 3 to the negative 1 power, because it's 5 minus 6 power. So this is just going to be 1 over negative 3 to the first power, which I don't need to do that. That's just negative 1/3. Okay, this one here. This is 1 over 5 to the 7th power times, now this is negative power in the denominator, so it's going to go in the numerator. That's 5 to the positive 4 power over 1, which is going to be 5 to the 4th power over 5 to the 7th power, which is 5 to the negative 3 power, which is 1 over 125. Okay, and that leaves us with this one here. So 4 to the 5th power times 4 to the negative 3, that's going to be 4 to the 2nd power over 4 to the 2nd power, which just happens to be 1. Okay, so there you go. Simplify negative 5 times x to the 0. Okay, so x to the 0 power, remember we said anything to the 0 power is 1. Now, remember, it's only what's immediately in front of the power, so the only thing getting taken to the 0 power is the x. So this is negative 5 times 1, which is negative 5. There's a difference between this and that. This would just be 1. Okay, but this, I'm only taking the x to the 0 power, so that's the only part that's 1. All right, let's simplify this. So I could use my my quotients of exponents rule. This would be negative 3 minus minus 5, so this would be 9 times y to the negative 8 power, which would be 9 over y to the 8th. Okay, a drop of water leaks from a faucet every second. How many liters of water leak from the faucet every hour? Remember, a drop of water is 50 to the negative 2 power liters. Okay, so if I take 50 to the negative 2, that's 1 over 50 squared, which is 1 over 2,500. So one drip is 2,500th of a liter. Okay, so it's going to take 2,500 drips to make a liter of water. So let's see, I want to know how many, that's every second. I need to figure out how many seconds are there in an hour. Well, there's 60 seconds in a minute, and there's 60 minutes in an hour, which means there's 3,600 seconds in an hour. Okay, so I'm going to take 3,600 times 1 over 2,500. And I'm going to get this, which I can go ahead and cancel off those. And so I'm going to get 36 over 25. That's what, 1 and 11 25ths liters. Okay, or let's see, 11 25ths is 0.44, so I could say it's 1.44 liters. Ends up being quite a bit of water. Imagine that running all night or something. Okay, so we're going to get to do 1 through 39, the odd ones. I will see you guys in class. Have a great evening.